Hello everyone, today we'll be solving the problems from SAT Panda math book, the second edition, topic percent. So I've already prepared all the questions here. So, okay, I've already highlighted the answers and we're gonna look at them one by one, okay? Let's get started. So let's look at the first question. It says, if x is 50% larger than z and y is 20% larger than z, then x is what percent larger than y? Well, there are different ways that you can approach this problem. The one that I prefer is to give the values for x, y, and z. Okay, it says, if x is 50% more than z, then we can say that if z is equal to 100, then x is equal to 150 because x is 50% more than z. Y is 20% larger than z, then y is 120. And now we need to understand x is what percent larger than y. So we need to compare these two numbers. So we need to compare x to y in percent. In order to do that, let's just make up a proportion. So let's just take 120 as 100% and 150 meaning x as, let's say, 8%. In this case, we need to find a. So let's just cross multiply. 120a is equal to 150 and two zeros. Let's just cancel two zeros and a has to be equal to 125%. So if a is 125%, meaning that 150 is 125%, and 120 is 100%, it is 25% more. So x is 25% larger than y. And remember that if you're comparing two numbers, let's say a to b, you always take the second number, the one that you're comparing to, as 100%. In order to understand like by what percent a is larger than b. Let's look at number 2. Veronica has a bank account that earns n% interest compounded annually. If she opened the account with $200, the expression represents the amount in account after t years. Which of the following gives x in terms of m? Well, in this case, we need to use compound interest formula. Compound interest. So this is a times 1 plus m divided by 100, because it is said that it earns n% to the power of t. That's going to be a times, well, in this case, a is initial amount, so we can say that it is 200, 1 plus, in this case, we have 1m here, 1, so that's going to be 0.01, because 1 divided by 100, m to the power of t. So we have this expression, and x is in the brackets. So what we do have in the brackets? That's 1 plus 0.01 m. So the answer would be A. Let's look at number 3. It says, in a survey of 400 seniors, X% said that they plan on majoring in physics. One university has used this data to estimate the number of physics majors it expects for its entering class of 3,300 students. If the university expects 66 physics majors, what is the value of x? Well, okay, so basically we have 3,300 students, the incoming class, and there are 66 students out of this much that they plan on majoring in physics. So we need to understand what does 66 make of 3,300 in percent. Okay, so we can do like this. So we can just divide 66 by 3,300 and multiply that by 100 to turn it into percent. So we just cancel two zeros. 66 and 33 will cancel each other. So the answer is 2%. So the answer is 2%. Let's look at number 4 to 7. The table below shows the number of box spring and mattress units sold over 4 weeks at a bedding store. Which week accounted for approximately 32% of all the box springs units sold? Well, we just need to do like this, okay? So if in order to understand, so the first week we've sold 38 box springs. Second week we've sold 42. Third 53, and etc. So we need to understand. Okay, so if we want to calculate, let's say for week 1, let's just divide 38 by 167 and multiply that by 100 to understand, okay, what does first week account in percentage for the all the box springs units sold. Well, for that, let's just use a calculator. So 38 divided by 167 times 100. That's approximately 22%, 8%. But we are asked to find the one that is approximately accounts for 32%. So the week 1 is not our answer. So we can just erase it. So let's calculate week 2. This is the same thing, 42 divided by 167 times 100. Okay, let's just calculate that as well. 42 divided by 167 times 100. That's going to be 25%. Okay, that is also not our answer. So let's just take 53 divided by 167 times 100. That's going to be around, well, let's just write week 3. That's going to be 53 divided by 167 times 100. That's approximately 31.7, which is approximately 32%. That's why the answer is C. Let's look at number 5. Approximately what percentage of all units sold came from week 2? Well, in week 2, we total sold 103. And in total, we've sold over 386. And in order to understand that, we just divide 103 by 386 and multiply that by 100% in order to understand approximately what percent of all the units sold specifically came from week 2. We just divide week 2, all the units that we've sold, by the total amount that we've sold. So that's gonna be 26.7. That is an approximate number, so that's the answer is B. Okay, let's look at number 6. Mattresses accounted for approximately what percentage of all units sold during week 1? So let's just look at the unit week 1 specifically, like this, this column. So in total we had 85, right? So, and how many mattresses did we have? So we've sold 47 mattresses, and in total we have 85 sales. So let's just multiply that by 100% as well. Okay, that way we understand what percentage does the mattresses account, specifically mattresses, out of all the total units sold. So that's going to be 55.294, etc. So that's exactly 55. That is approximately 55.3%, which makes the answer. Okay, let's move further. Let's look at question 7. What was the approximate percent decrease in the number of mattresses sold from week 3 to week 4? Okay, that is a good question. Okay, so in week 3 we had 68 mattresses, and in week 4 we have 48 mattresses. So it was 68%. Let's make it 100%. So we had 100% mattresses, basically 68 mattresses, and now it became 43. So it became X percent. We don't know to what percent did it decrease. Let's just cross multiply. 68 times X is equal to 43 300. So x is equal to, let's just calculate that. That's going to be 63.23. So, but this is not an answer. Why? Because they are asking us what was the approximate percent decrease. So they're asking us for the change in percentage. Now we just have to, subtract. So that's going to be 36.7%. And the closest one is 37, so A is our answer. Let's look at number 8. The discounted price of a book is 20% less than the retail price, okay? So let's look at the retail price is, let's say, X%, okay? And the discounted price is 0.8%. X dollars, let's just call it X dollars, 0.X dollars, okay? James manages to purchase the book at 30% of the discounted price at a special book sale. What percent of the retail price did James pay? Okay, this is pretty easy question. You can actually solve it using, just going not with numbers, but going mathematically speaking. You just solve that by using x and numbers, but the best way to do that is just give some number. Let's say that the retail price is $100 and the discounted price is $80, and out of this discounted price I get one more time the discount of 30%, meaning that now the price is 70% of $80. So in order to find 70% of $80, I just multiply 0.7 by 80. That's going to be $56. This is our answer. Let's look at number 9. Each day, Robert eats 40% of the pistachios left in his jar at that time. At the end of the second day, 27 pistachios remain. How many pistachios were in the jar at the start of the first day? Okay, let's say days. So we had day 1 and day 2, okay? Or we can actually make it like this. Day 1 and day 2. This is day 1 start. Okay, let's just call it start, end, start, end. Okay? It says each day Robert eats 40% of the pistachio left in his jar at that time. Okay. At the end of the second day, so let's say in the beginning he had, let's just call that X. We don't know how much he had, so let's just call that X. And at the end of the day, so he ate 40%. Okay, so what is he left with is 0.6x because he ate 40% of it. Okay, so in the beginning of the second day he had 0.6x, and after he ate 40% more, meaning that he ate 40% of 0.6, so 0.4 times 0.6x, and how much is he left with? 27. This would be our answer. Now let's just calculate that. Okay, let's just divide 27. Let's just divide 27 by 0.4 times 0.6. And this would be our answer. Oh, sorry, maybe I made a mistake somewhere. Let me just recalculate that. And maybe I made a mistake somewhere. Let's just take a look. Oh, sorry. I was supposed to multiply not by 0.4 here, but 0.6. Why? Because he ate for it, as I said, he ate 40%. So 0.6 is left. Okay, now let's just divide by and that would be 75. That would be our answer. Okay. Let's look at number 10. It says Joanne bought a doll at a 10% discount of the original price of 105.82. However, she had to pay a sales tax of X% on the discounted price. If the total amount she paid for the doll was $100, what is the value of X? This is an interesting question, okay? Okay, so the original price was $105.82, and then she got a discount of 10%, meaning that she bought not for 105.82, but she got it for the reduced price of 10%, meaning that we need to find 0.9 off this number. Why? Because initially it was 100%, now it is 90%. However, she had to pay a sales tax of X% on the discounted price, meaning that after she bought, so let's just now calculate the first one. Okay, so that's going to be 95.238. So that's how much she bought it from, and then only after she bought it at a discounted price, she had to pay a sales tax of X%, meaning that, do you know what is a tax basically? This is the money that you pay to the government for buying something. This is usually in most of the countries like 3%, 2%. Well, I'm not sure. Of course, it depends on where you live. But so, okay, so let's just calculate it as this. So it was 95.238, but after she paid X%, it became $100. Okay, so we need to make a proportion, and in this case we need to decide what to put, whether to put 100% here or whether to put 100% here. Okay, and the question is what are we comparing to? So if you remember, I told you, if we're comparing two numbers, let's say A to number B, the interesting thing is that if we compare A to B, we always take B as 100%. And in this case, we need to compare the price, the discounted price, to the total amount that I paid, in order to understand what percentage did it increase. So let's just take it as 100%, and let's just take it as X. Now let's just cross multiply. That's going to be 95.238X. It's equal to, and X is equal to, now let's just calculate that. That's going to be 105.000105. Well, that's approximately 105. So if this is 105%, what percentage did it increase? Well, 5%. The answer is D. Let's look at number 11. So in 2010, the number of houses built in town A was 25% greater than the number of houses built in town B. So let's say A, B, the year 210. So let's say that the number of houses built in town B was 100, and in town A, because it was 25% greater, it is basically 125. If 70 houses were built in town A during 210, okay, so so basically the amount was 70 houses. Okay, so it is 100%, this 125%. Let's just make a proportion. That's going to be 125 equal to 70, and 100 is equal to X. And now let's just solve that. 125X is equal to, let's calculate that. That's going to be 56. So in 2010, like here, 56 houses were built in town B. The answer is 56. Let's look at number 12. Over a 2-week span, John ate 20 pounds of chicken wings and 15 pounds of hot dogs. Okay, let's just write chicken wings. just write hot dogs. There are 20 pounds and then 15 pounds. Kyle ate 20% more chicken wings. Okay, so 20% more and 40% more hot dogs. So 40% more hot dogs. Considering only chicken wings and hot dogs, Kyle ate approximately X% more food by weight than John. Okay, so let's just call that John, and then we have Kyle. Okay. Well, first of all, let's calculate. So if John ate 20 pounds of chicken wings, Kyle ate 20%, meaning that we need to multiply 20 that John ate by 1.2. Why 1.2? Because initially John ate 100%, but because Kyle ate 20% more, Kyle ate 120% of what John ate. So that's going to be 1.2 times 20. That is 24 pounds. This is basically Kyle. Okay. And 40% more hot dogs. So that's going to be 15 times 1.4. Okay. So that's 15 times 1.4. This is 21 pounds. This is Kyle as well. And in total, he ate 45 in pounds of food. This is Kyle. What about John? He ate 20 plus 15, 35 pounds. And now we need to compare 35 pounds to 45. So 35 to 45. So 35 would be our 100%. Let's make up a proportion, and 45 would be just X%. Let's just cross multiply. 35x is equal to 4500, and x is equal to 4500 divided by 35. This is approximately 128.57. So that's approximately 129. So he ate 29% more. The answer is C. 129% minus 100% is equal to 29%. Let's look at number 13. Jane is playing a board game in which she must collect as many cards as possible. On her first turn, she loses 18% of her cards. So first turn, she loses 18%. Okay. On the second turn, she increases her card count by 36%. Second turn, she increases by 36%. Okay. If her final card count after these two turns is n, so the final is n, which of the following represents her starting card count in terms of n? Let's say that the starting amount that she had is just x. So she had x, then she lost 18%, meaning that she had 100%, meaning 1 minus 0.18. She lost that much. And then what happened after the second turn? She got 36% more. Then she had 1 plus 0.36. And that is equal to n. In this case, x is equal to 1 minus 0.18 is just 0.82 times 1.36 is equal to n. And in this case, we need to find x. So x would be equal to n divided by 0.82 times 1.36. This is exactly our answer C. So here's your answer. Let's look at number 14. Due to deforestation, researchers expect the deer population to decline by 6% every year. If the current deer population is 12,000, what is the approximate expected population size 10 years from now? Okay, this is just compound interest formula that we can use. Compound interest formula. So a times 1 plus r divided by 100 to the power of t, where a is the final amount, r is rate, and t is time. So let's just calculate that. So a initial amount 12,000 deers that we have, t is equal to 10. We need to calculate the approximate expected population in 10 years. and it is declining by 6%. So rate is equal to minus 0.06 basically. Or we can just make it, minus 6%. Okay. So 12,000, 1 minus 6 divided by 100 to the power of 10. Now we need to calculate that. That's 12,000 times 0.94 to the power of 10. Well, for that we need to use the calculator. 12,000 times 0.94 raised to the power of 10. That's gonna be, oh no, I've calculated it incorrectly, sorry guys. So we're gonna write 6% every year. So let's just go 12,000 times 0.94 to the power of 10. So we have 6,463. This is the number that I'm getting. Yes, the closest answer is B. So the answer is B. Let's look at number 15. Kyle bought a 2,000 government bond that yields 6% in simple interest each year. Which of the following equations gives the total amount A in dollars Kyle will receive when he sells the bond after T years? Okay, this is the same formula that we can use. Okay, let me just copy that. Let's just copy. So the initial amount is $2,000. So $2,000. 1. So we have a increase of 6% each year. So after T years, that's going to be 2,000. 1.06 to the power of T. This is basically the formula that we need. Okay. Well, in this case, I made a mistake. It should be something like this. So the answer is 6 simple. It is simple interest. Sorry guys. This is not a compound interest. We didn't need to copy that. It is a simple interest. So for simple interest, we use a different formula. This is just formula for mx plus b for linear function. So that would be just 2,000 multiplied by 1 plus 0.06 times the time. Why? Because look, this is the initial amount that I have, and then because I need to find in T years, I don't know, let's say in 3 years. So every year I have a increase of 6%, and then 6%. So the overall increase would be just 0.06, 0.06, let's say 3 times. And in order to calculate that, I multiply 0.06 by 3. This is exactly what this formula is doing. So the answer is B in this case, because we used the simple interest, not the compound interest. Let's look at number 16. Okay, a small clothing store sells 3 different types of accessories. 20% are scarves. Okay, so scarves is 20%. Ties is 60%, and other 40 accessories are belts. Belts is basically 40. If half of the ties are replaced with scarves, if half of the ties, so if 30%, let's just don't do that. Okay, let's say half. Okay, half is basically 1/2 with scarves, so we take and give it to them. How many scarves would the store have? Okay, so well, if there are 20% of scarves that we have, 60% of ties, then that's going to be 80%, right? So meaning that we have the 40 of belts represents the same 20%. Whereas X, let's just say we have X ties. It's basically 60%. Okay, now let's just calculate the number of ties that we have. Cross multiply that times 60. Let's just reduce them. 120. So we have 120 ties. And because we're replacing half of ties, half of 120, so half is 1/2 of 120 would be 60. So we took 60 ties, and instead of them, we added that many scarves. So we had 40 scarves plus 60 now. Now we have 100 scarves. How many scarves will the store have? 100. This is our answer. Let's look at number 17. Oh, this is a good big question. Daniel has 1,000 in checking account. Okay, let's say checking account. So he has $1,000 and 3,000 in savings account. Savings account, $3,000. The checking account earns him 1% interest compounded annually. So 1% compound interest. Okay. The savings account earns him 6% interest compounded annually. So this one earns 6% compounded annually. Okay. Assuming he leaves both these accounts alone, which of the following represents how much more interest Daniel would have earned from the savings account than from the checking account? Well, let's first calculate the interest that Daniel will get from checking and from saving. Okay, because it is a compound interest, we need to use this formula, compound interest formula. So let's say for the checking account, so the initial amount is $1,000 and he's earning 1%, meaning that that's 1 plus 0.01 to the power of after 5 years. So let's make it 5. Whereas for his savings account, that's 3,000. 1 plus 0.06 to the power of 5. But these two formulas at this stage will give me how much money I would have had at the end after 5 years. But I want to calculate the interest that I've earned, meaning that, let's say in the end I had 5,000, but I've invested 1,000. In order to calculate the interest, I just need to subtract from the final amount the initial amount. Well, the initial amount is basically, let's just subtract, is basically $1,000. In this case, this is minus $300. Well, and now in order to understand how much more savings account earned than checking account, we need to subtract this amount, well, this amount from this amount. So savings interest minus checking interest. So this is basically gonna be 3,000. That's 1.006 to the power of 5 minus 3,000 minus 1,000 times 1.001 to the power of 5 minus 1,000. Let's just take it as this. And the answer is C. I hope you understood. This is pretty difficult question, but I hope you understood what I meant. If you didn't understand, just rewatch what I've said, what I've explained, and then I hope you will understand. Let's look at the last question. It says, Kristen opens a bank account that earns 4% interest each year, compounded once every 2 years. If she opened the account with K dollars, which of the following represents the total amount in the account after 2 years? Well, this is a pretty good question, okay? we have 4% that compounds every 2 years. Okay. Okay, if we have we had this formula as well. So 1a 1 plus r divided by 100 to the power of t divided by m in this case. Okay, so let's just take a look at how we would solve this question. Oh, sorry. Like this. M times r. This formula. Okay, so where m is the number of compoundings that we have. Okay, so it says the initial amount is k, so we have k dollars, and then 1 plus, in this case, the number of compoundings once every 2 years, meaning that if in year 1 the compounding was 4%, the second year would be 4%. So in 2 years, the overall rate would be 8%. So because we're counting not every year, but every 2 years. So 4% for the first year annually, then for the second year 4%. So the rate is, in this case, so basically 2 times 0.04. So that's going to be 8 divided by 100 to the power of, and because it is compounding every 2 years, that's going to be t over number of compoundings is basically just 2. So that's going to be k times that's going to be 1.08, yes, t to the power of 2. And yes, the answer is D. You can take a look at all the solutions. You can take a photo of every one of them. Okay. That was basically the second topic, the percentages, all the solutions to all the questions. Okay.